Hello friends, in the previous video we created a render window. In this video I will show you how to draw a simple triangle in that window. Since we are using modern OpenGL, we should use shaders. In order to draw a triangle, I will create a simple shader program that has a vertex shader and a fragment shader. Okay, let's start with vertices of the triangle. Triangle has 3 corner points, so we need 3 vertices. Since the triangle is a 2D shape, it is enough to have only x and y coordinates. But in future, we will be working with 3D objects. So let's use x, y and z coordinates. For now, z coordinate is 0. And at this point, we only have normalized window coordinate system, which means coordinates should not go beyond +1 or -1. In the window coordinate system, x-axis goes from left to right. Left edge is -1 and the right edge is +1 on the x-axis, and the y-axis goes from bottom to top. Bottom edge is -1 and the top edge is +1 on the y-axis. Center of the window is the 0, 0 coordinate. Okay, now let's create a float array to store our vertex coordinates. We have 3 vertices with x, y and z values. So we have 9 values in this array. Okay, now let's create our shaders. In case if you don't know, shaders are separate programs written in language called GLSL. These programs will be compiled and loaded into our main program at runtime. Vertex shaders are used to manipulate vertex coordinates and it runs per vertex. That means if you are rendering a triangle, vertex shader runs 3 times because the triangle has 3 vertices. The output of a vertex shader can pass into a fragment shader. The fragment shader runs per pixel and it is used to manipulate pixel color on the render window. We will talk more about shaders in future videos. Okay, let's write our vertex shader. We need an input attribute called position to hold our vertex position. And the variable type is vec3 that represents 3D vector. This vertex shader program does not do anything but pass the input value to the output value. And the output should be in vec4 type. So we add 1.0 to the last parameter. Okay, then let's write our fragment shader. This is also very simple and the only thing it does is set red color as the fragment color. Here also output should have the vec4 type and it represents RGBA value. Okay, now let's create the vertex shader. Object IDs in OpenGL has unsigned int type. So let's create 3 unsigned int variables to hold vertex shader, fragment shader and shader program. First we create vertex shader passing GL vertex shader type to the GL create shader function. Then we set the vertex shader source. Then we need to compile it. Since the compilation happens at the runtime, we will not be able to see the compilation errors. So we have to write additional code to see the compilation errors. I'm not going to write that code here, but I will put it in the description. So if you have any issues with shaders, please copy that code to this place and it will print errors on the console. Okay, now let's create the fragment shader. Same as the vertex shader, we need to create fragment shader first and then we need to set shader source. And then we need to compile it. Again, if you need to check for compilation errors, put the code here from the description. Okay, then create a shader program and we need to attach vertex shader and the fragment shader to the shader program. Then we need to link the shader program. Now the shader program is ready. So we don't need the vertex shader and the fragment shader anymore. So let's delete them. Next, we need to create vertex array object. We call them as VAO. VAO stores all vertex attribute status. So it helps to reduce the amount of code we have to write and also has performance benefits. After creating the VAO, we need to bind it. Okay, then let's create a vertex buffer object or VBO. that used to upload vertex data. Then again we need to bind it. And then we need to initialize VBO with our vertex data. First parameter is binding target. Second is the size of data array in bytes. Third is the pointer to the actual data. And the final parameter tells how to use the data. In this case, we just need to draw, so we put glStaticDraw. Then we need to pass this data to the shader via attributes. For that, we use glVertexAttribPointer function, and the first parameter is the starting index. The second parameter is the number of components. Since we have x, y and z coordinates, we put 3. Then the type of data, which is float. Then we pass false to tell that the data should not normalize. And next tells the size of the vertex attribute, which is the size of 3 float values. Final parameter is the offset of the first vertex attribute. Since we only have vertex positions in this buffer, we pass 0 as a void pointer because the function expects the offset type as a void pointer. Now we need to enable the vertex attribute at location 0. This relates to the input variable called position that we added in the vertex shader. Okay, now we are going to draw a red color triangle on the window. Then what will be the background color? If you don't set the background color, it will be black. But you can change it using glClearColor function. Here I will use blue color as the background color. Okay, now every time the game loop is run, we have to erase everything in the window before draw anything. To do that, we use glClear function with glColorBufferBitFlag. Now we created all the things that we need to render a triangle on the screen. So let's render it. First, we need to set the shader program. Then we need to bind the VAO. And then we can draw our triangle using glDrawArrays function. First parameter is the drawing type. We can draw only primitive types such as lines, triangles and quads. Second parameter is the first index of the vertex data array. And the third parameter sets the shape count that we need to draw. Okay, now let's run this application. As you can see, you have a red triangle in blue background. Okay, see you in the next video and thanks for watching.